feel the vibe.
What's up, guys? Welcome back to another Algebra 2 lesson here with Mr. Gaines as we continue our work with arithmetic sequences. Today we are going to look at operations involving finding the terms of an arithmetic sequence. So as we learned in our previous video, arithmetic sequences are a series or sequence of numbers where there's a common difference in between each of the numbers. And we can find terms, we found terms by taking the previous term and adding to it, essentially following a recursive formula for the arithmetic sequence. However, we have a general or an explicit formula for the arithmetic sequence as well that we can use to find the nth term, any term in the arithmetic sequence. So this formula would be a sub n, the nth term, would be equal to the first term a sub 1 plus d, where d is the common difference, times the quantity n minus 1. So n would be the numbered term. So if we're looking for the third term, we would take the first term, add the difference times 3 minus 1. So in problem 3, let's take a look at an example here. It says find the 24th term of the sequence 0.1, 0.4, 0.7, 1, and so on and so forth. So they give us 4 terms, and we want to find what the 24th term would be. So a sub 24, the 24th term would be the first term, 0.1 plus the difference. Now we're going to have to do a little bit of work to find the difference. Remember in the previous video, we were able to find the difference by subtracting any of the terms. So I'm going to take the 4th term here and subtract its previous term, the 3rd term, and there I have the difference. I could do the same thing with, let's say, the 2nd term, 0.4, and subtract the 1st term, 0.1, and I have the difference. So this is increasing, so we're going to have a positive d value of 0.3. And now I can substitute into the formula. N would be 24 minus 1, and I can evaluate. So this would be 0.1 plus 0.3 times 23, and that would give us to the 24th term. So the 24th term would be 7. So again, we could find this by just adding 0.3 to each term. So 0.3 plus 0.3 plus 0.3, and keep going and do that 23 times to get from the first term to the 24th term. But what this does right here is it takes the first term and it adds 0.3 23 times in a much shorter fashion using multiplication. So let's see if you can use the video to let's see if you can pause the video and use the formula to complete problem number 4. So hopefully you got an answer for problem number 4. Finding the 12th term of a sequence may not be too bad. You can find the difference and add or subtract that difference 12 times, but what we could do instead, again, is use the formula. So if we want the 12th term, we're going to take the first term, and in this case you may notice that the difference is a negative number. The difference between each is negative 3. And then this would be times 11 minus 1. So the 12th term, a sub 12, would be 7 minus 3 times 10, which would be negative 23. So that formula can allow us to quickly find any term. Again, this is going to be very useful if maybe we had to find the 100th or the 1000th or the millionth term in a sequence, where using the recursive idea of just adding the difference repetitively would be very redundant and take us a long time. We can get there very quickly. Let's take a look at some other examples where we can use the sequence, or sorry, the formula, this explicit or general formula for a sequence. In problem number 4, it says find the number of terms in the arithmetic sequence 2, negative 5, negative 12, negative 19, all the way up to negative 411. So in this case, we're not finding a specific term. We're finding out how many terms existed here. And so what we need to do is we need to take a look at this equation, and we're going to have to solve for n. Now, how we can do that is we can take the final term and substitute that in for a sub n. Now we don't know how many terms it takes us to get there, but we know the value of that term is going to be negative 411. We know the value of the first term is 2. And then we can find the difference here. You may see the difference is negative 7. So again, I could take like the second term and subtract the first term to find that difference. So my difference is negative 7. So I'm going to substitute in a negative 7 for D. I don't, again, know how many terms there are to get me to negative 411. So I can leave n as a variable and now solve for n. So we can solve for n by following reverse order of operations or SADMAP to get n by itself. So I'd take negative 411 and I'd subtract both sides by 2 to give me negative 413 equal to negative 7 times the quantity n minus 1. And I could distribute that negative 7 if I wanted to, but instead I'm just going to divide by negative 7. I'm going to divide both sides by negative 7, and that gives me 59. So n minus 1 is 59. I would add 1. N would equal 60. So there are 60 terms here in this expression or this sequence. So it starts at 2, and in the 60th term there would be negative 411. Now we could check that by using the formula. So I could take the first term, 2, plus my difference, which was negative 7, times 60 minus 1, or 59, and make sure that that is negative 411, and it is. So it's going to be 60 terms to get us to that value. Now, problem number 5 is a little bit more complicated. It's not just direct substitution. In the rest of these, we did some direct substitution in problem 3 and 4 to find the terms there. And then in problem, sorry, that looks like we have 2 problem 4s. But in the second problem 4 there, we did a substitution and then a little bit of solving. Here in problem number 5, it says, given the arithmetic sequence where a sub 6 equals 0.55, so the 6th term is 0.55, and the 13th term is 0.9. Find the common difference D and the value of the first term. So in this case, we're actually looking for 2 different things. But if you think back to the systems of equations, we can create a systems of equations that we're going to be able to solve here. So the 6th term, let's start there. The 6th term would be 0.55. So if I go back to my general or explicit formula here, 0.55 can go in for n. So, sorry, 0.55 can go in for a sub n. Then a sub 1, the first term, we don't know right now. So I'm going to leave that as a variable. D, we also don't know D right now, so I'm going to leave that as a variable. I do know what n would be in this case. If the 6th term is 0.55, then n is 6. And so this equation can simplify to 0.55 equal to a sub 1 plus 5d. Now, I could create a second equation. So this first equation came from the 6th term. We knew the 6th term. I can create a second equation from the 13th term. So the 13th term is 0.9, so that's going to go in for a sub n. Again, I don't know the first term, so I'm going to leave it as a variable. I don't know the difference, so I'm going to leave that as a variable. I do know that the 13th term, n would be 13, so I can put in 13 and simplify. So now I would have 0.9 is equal to a sub 1 plus 13d. And this gives me a system of equations that I can work to solve. So here the easiest thing to do would probably be to subtract each of the values. So if I subtract, I'm going to get 0.55 minus 0.9, and I can do that in the calculator if need be. This would be a negative 0.35. The a sub 1s would subtract out as hopefully they do in a system of equations to eliminate that variable. And then I could have 5d minus 13d, which would be negative 8. Now, if I want to get d by itself, I can divide by a negative 8 here. So I can take negative 0.35, divide it by a negative 8, and I can get my common difference. My common difference is going to be a decimal, which we can list it as a decimal, but I'm going to go ahead and turn it into a fraction. This fraction is 7 over 160. Oh, sorry, guys. I actually have a mistake here, and hopefully you caught this mistake prior to what I just did here. You did not go any further. Hopefully you caught this mistake when I simplified. I did not actually simplify correctly. So when I should have simplified here, I should have simplified 13 minus 1 into 12d. So in the secondary equation I created, I wrote down 13d when it should in fact have been 12d. Sorry about that error. But now again, we are trying to subtract, and so let's go back to where we were. We are subtracting these two equations. So this would give me a negative 0.35 equal to, instead, negative 7d should be the correct term. And then negative 0.35 divided by negative 7, d would be 0.05. Okay, so sorry about that error, but as we corrected the error, we find that the common difference is 0.05, which if you wanted to turn into a fraction would be 1 over 20. Either of these would be acceptable representations of your answer. Now we can use this to find the first term. So our common difference is 1/20 or 0.5. And then we can use this to find the first term by substituting into either of these two equations. So I'm going to choose this first equation here. I'm going to substitute in the 1 over 20th. So I'm going to have 0.55 equals a sub 1 plus 5 times 0.05 or 1 over 20. And so simplify that expression. So 0.55 equals a sub 1 plus 0.25. So as we take 0.05 times 5, and then I can subtract 0.25, and I would get 0.3 equals a sub 1. And there I have my initial term, a sub 1, and my common difference. Now we can check this pretty quickly in the calculator. So these were the two terms we knew existed in the arithmetic sequence. In my arithmetic sequence, I can check by going back to the general form or the explicit form of the arithmetic sequence and substituting this expression. So 0.3 would be my first term plus my difference 0.05. Instead of n, I'm going to list this as x minus 1 and then look at the table. So my first term is 0.3. If I go down here to the sixth term, it is 0.55, which we expected. And if I scroll down to the 13th term, it's 0.9. So here, if we are given 2 points or 2 positions, 2 terms in the sequence, if we're given 2 terms in the sequence, we can use the explicit formula for an arithmetic sequence to create a systems of equations that we can solve then for the first term and the difference. So this is how we can find terms and use the explicit formula for an arithmetic sequence. This is a good place to stop. As always, thank you guys for tuning in, and I'll see you.